All right. Good evening, good evening, good evening, good evening to all the grade 12 students. Welcome back, welcome back. Yes, we've successfully completed three chapters in our last 30 days revision, right? So, out of the seven chapters, we have completed three. Very soon, we are going to complete the remaining. Nothing to worry, students. Gradually, we'll be doing all till your board examinations. I think by 25th, all your chapters will be done. Yes, yes. So today we are going to start the most important chapter and expected chapter, DNF block. Yes, so the series, DNF block series, very important. I'll be including MCQs, 1 mark, 2 mark, 3 mark, 5 mark question and answers. So in this particular video or in this particular series, I'll be also teaching you answer writing skills. Answer writing skills also I'll be teaching you for DNF block. I'll be giving the reasons, I'll be telling you how to write the answer also. All right, let's not waste time. Let's start with the D&F block. Very soon we are going to complete and we are going to score 95 plus. So which chapters did I complete? I have completed. I have already done solution chapter. I have done halo alkanes and halo arenes. I have also done your electrochemistry. Yes, so I'll be sending you the MCQs for electrochemistry very soon, students. Okay, solutions also, nothing to worry. Let's start the series. First question. Mostly in your DNA block, graphical based questions are very important. Compulsory graph based questions because they're going to give you a graph which is in NCRT. So graph, once they give you, they'll give you 5 or 6 questions below to answer. Let's read. What do they give? I'll give you. Observe the graph of transition metal or metals and their melting points and answer the questions based on weak metallic bond, which is due to absence of the graph and related concepts. What did they say? They are talking about, they've given you a concept based on weak metallic bond. Okay, answer the questions. I have to keep into consideration that weak metallic bond. Okay, and this is not mentioned in the graph because I can't show that weak metallic bond in the graph, right? And whatever related concepts are there, they're asking you to write. Sure. Nothing to panic. Let us see the first question and see. What do they give me here? They have given me first transition series. They have given me second transition. They have given me third transition series. Nothing to by heart in the graph. Concept is important. Let's start. What did they give me? So first of all, they said first question goes like this. Why does tungsten W has highest melting point and is colorless in aqueous solution? They give me why is tungsten having highest melting point, melting temperature here, and along with that, it is also colorless in aqueous solution. They're asking you to answer in which one? They're asking you answer in terms of weak metallic bond and the electrons. So talk in that terms. First of all, what is tungsten electronic configuration? For you, electronic configuration is very important. You need to learn electronic configuration of this everything. But if you don't remember in the exam, they'll give you atomic number. Okay, they'll give you atomic number. With that, you can write the electronic configuration. So for me, the tungsten atomic or the electronic configuration is xenon. Okay, now 6s2, then 4f14, then 5d4. This is tungsten electronic configuration. Now you only tell me tungsten has high melting point and it's colorless. So first of all, tungsten, what are you finding, students? What are you finding in D block? D block, how many electrons are there? In 5D series, let us so this is fulfilled. This is also completely filled. In D block, when I take 1, 2, 3, 4, 5. 1, 2, 3, and 4. Okay. So what are here? Unpaired electrons. So in D block elements or particular thing in D 5D series. So I'll write in 5D series. How many unpaired electrons are there? There are unpaired electrons. In 4D, 4D, do you have 4D here or you have 4F here inside? Okay, 4F is completely filled. So 5D series, if I have to take this 5D series, in this particular thing, it has unpaired electrons. Okay, it has unpaired electrons. Because of unpaired electrons, what will happen, students? They ask you to talk in terms of metal bond. So I will write in 5D series, it has unpaired electrons and there is more frequent metal bonding because unpaired electrons are there. The next element, it starts bonding with which one? 5D series element and 3D and 4D series. what will it do? Because of the presence of unpaired electrons, it forms which one? Metal bonding, metal bonding. They asked me to talk in that terms, no? Yes, if I did, then what will happen with metal bonding in which one? And 3D and 4D. So it'll try to form a bond with that, because of which, hence, MP is high. MP is high. That's it. You are going to write the answer like this only. They're not talking about colorless and aqueous solution. They've given you a condition. So just talk in terms of bond or weak atomic interactions, weak attractions. So what did I say? I started with unpaired electrons. Then I said it forms metal bonding, because of which melting point is high. Easy, easy. So clearly it is due to the presence of unpaired electrons, and there is more frequent metal bonding in 5D series, and that too then compared to your 3D and 4D. So this is the key word in done, students. Let us go to the next question gradually. Next question. Which element in 3D series it has lowest enthalpy of atomization? Again, talk in terms of metal bond. Okay. Which element has lowest enthalpy of atomization? Breaking. Just see. Here, silver is there, Au is there, copper is there. Lowest enthalpy of atomization, manganese. Can I see from this graph? Can't see. So remember, among all the series, that particular 3D series, zinc has lowest enthalpy of atomization. What is the reason? Enthalpy, lowest enthalpy of atomization. Enthalpy of atomization. Why it has lowest enthalpy of atomization? I'm not writing completely, just reason. Yes, let us write the configuration. Zinc configuration is argon 3D10 4. Argon 3D10 4. So now tell me, is there any unpaired electrons? Right? So zinc has lowest enthalpy of atomization because of due to absence of unpaired electrons. There are no unpaired electrons here. Because of this absence of electrons, it's completely filled. Then when it is completely filled, highly stable, will it break? Will it separate into atoms? No. Lot amount of energy is required. So zinc has lowest enthalpy of atomization. You'll write this. You'll write reason. Zinc electronic configuration is this. Due to absence of unpaired electrons, it has lowest enthalpy of atomization. Lowest enthalpy of. Can I write this? Done. The section is done. Let us go to the next question and read. Why mercury is liquid? Why it is a liquid? Where is mercury in this graph? Mercury given Hg. First of all, the graph will just give me the trend, but does it give me any position, or will it give me maximum factors? No. They asked me to talk in terms of metal bond. That means nothing but electrons, electronic configuration. First of all, mercury is a liquid. Reason is mercury is having larger size. This atomic number, correct? Let us write configuration first. Mercury, the electronic configuration is xenon. It has, first of all, it has 4f14 completely filled. Then it has 5d10. This is completely filled. Then it has 6s2. This is also completely filled. Now you tell me, due to, first of all, mercury has larger size. You're seeing the atomic orbitals, right? Larger size. First thing. Are there any unpaired electrons? Yes. Absence of unpaired electrons. Absence of unpaired electrons. So done. Absence of unpaired. Now what else, students? Because of this absence of unpaired electrons, what will happen? Weaker, weaker inter, or weak interatomic attractions. The interatomic attractions. Okay. Weaker interatomic attractions. Because of this, what will happen? It will have weaker metallic bond. The metallic bond. Now, because of all these reasons, mercury is a liquid. Well, hence mercury is a liquid. You'll write the answer, hence mercury is a liquid. You'll write here conclusion like this and write hence mercury Hg is a liquid. Is the students very easy? You're just going to write in this term, finish off your answer. Next question, let us go. Why are transition elements electropositive in nature? Okay, what is electropositive basically? Electropositive means ability of an electron to donate electrons. Ability of a particular metal to donate electrons. Electropositive donating. Electronegative means dragging the electrons. Now, first of all, I have to talk in terms of that. So start talking. Transition elements start from atomic size. Transition elements or atoms have smaller atomic size. Correct? They have smaller atomic size. Why they have smaller atomic size? As you know, there's a concept of lanthanide contraction arising, right? That concept reflects. Now, because of the smaller atomic size, what will happen to the ionization enthalpy? Higher ionization enthalpy. I require lot amount of energy to pull out the particular electron enthalpy, higher ionization enthalpy. Okay. Because of higher ionization enthalpy, why this is higher ionization enthalpy? Because since since nuclear charges, because nuclear charges size is small, right? So the nuclear charges high. The charge is very high. This is also okay, done. Then now you say small size is there, higher ionization enthalpy is there. Why? Because of since nuclear charge is very high, that you wrote it. Now, because of this high nuclear charge and everything, will it donate electron easily? Will it donate electrons easily to others? It's difficult, right? Yes. So the block elements, whichever has larger size, easily it can donate, because the distance between nucleus and outermost electron is more. That's why down smaller size, higher ionization enthalpy, since nuclear charge is very high because of the because of the cause of the size. That's the reason. That's the reason it is difficult difficult for transition metals to to donate electron, hence less electro less electro. Okay. Easy, write the same answer, you'll get full. Next question. Did they give me anything else? Okay, this particular part, as I said, remember students, always remember whichever concept is, you have to relate every question to which concept? To relate every question to your metallic bond or atomic interactions. Here they've given in the first question. Have you seen? I'm talking all in terms of this weak metallic bond. So weak metallic bond is a concept. So weak metallic bond means nothing but your atomic attractions. Correct, na? So talk in these terms, all the answers will be right. Let us go to the next question. How does density vary from left to right in 3D, 3D series, and why? Left to right, when you move, that is from scandium to copper. So when I from left, I'm start taking a 3D series. Scandium, I'm going towards copper. What will happen? What will happen? As you're moving from left to right, atomic mass atomic mass increases. When atomic mass increases, according to the formula, since density is equal to mass by volume, what will happen? Automatically atomic or automatically density, because both are directly related, density increases. When density increases, what will happen to the volume? Density increases as atomic mass increases, and because of atomic mass increases more than the atomic, so obviously it is related, these two will increase. Compared to that, atomic volume will be reduced. They are not asking about atomic volume, they are asking about density, so I wrote only that. Okay, so left to right. So atomic number increases, I'll write that also. Atomic number increases, atomic mass increases, density also. That perfect. Next question. We go to the next question. Next question. That is how it is given. There's one more table here. Let us read. Observe the table given below belonging to 3D series. Their first, second, and third ionization enthalpies. This is the concept. And electrode potential values is M plus 2 M. Electrode potential values plus 3 plus 2. Okay, so the cases M plus M, that means it is gaining electron. M plus 3 plus 2 is gaining 1 electron. Answer the following question. The concept is given, so you have to answer the following questions based on that. Okay, sure. There's one table. Ionization enthalpy is given. All electrode potential values are also they've given plus 2 2 plus and M plus 3 plus 2. Done. Now, for which series they've given? They've given for 3D series from scandium till zinc. See the questions. Questions. I have taken the table again. Why does zinc have first ionization enthalpy? Okay. Where is zinc? What is the ionization enthalpy of zinc? It's 905 kilojoules per mole. Why is the first ionization enthalpy compared to all these? This compared to all these, why is it max? They're asking. Sure. How should I write? I'm writing in terms of electronic. For zinc electronic configuration is in 3D10 4s2. Done, students? Yeah. When you compare 3D10 and 4s2, 4s is completely filled. Correct? Completely. Now, when this is completely filled, I'm trying to take out one electron using first ionization. First ionization. Is it easy to remove an electron from the field? It's very difficult for me. That's why you write an answer. Zinc electronic configuration is this. Second point, this 4s2 orbital is completely filled. Yes, removing one completely filled electron. I'll write that answer for you so that it is easy. You can directly write that in the equation, right? So, filled electron, and what happened? This also I'll erase. So, take out this. Go back. I'm taking an eraser. I'm erasing this. I'll write in terms of answers for you so that it is easy for you. Chalo. Zinc is completely filled. Now start writing. 4s2 or outermost shell or outermost orbital is completely filled. Completely filled and is stable. And is stable. Correct? Na? Stable. Now removal of electron 4s2 of electron using first ionization energy will be more. Correct? Na? Because since fully filled is more stable, fully filled is more easy. Let us go to the next question. Why is third ionization enthalpy of manganese high? What is manganese? Here, manganese. See this third ionization 2002, this is 2400, this is 2721, 2809 maximum. It's compared to zinc. Okay, zinc is completely filled, but manganese, why they're asking? Okay, third ionization enthalpy. Again, start with electronic configuration. Manganese electronic configuration is argon 3d5 by 4. Accepted. Now, ionization enthalpy, when I take out 3d5 4s1. Let us write argon, take out 3d5 4s1. This first ionization. First I take out one more argon. This is 5 4s 0. This is ionization enthalpy. Second I. Now you are trying to take out one electron from third using third ionization enthalpy. Now what happens when you came to third? This half filled configuration. My God, here you will write because why it is high, because you'll write third ionization energy manganese is high. Reason high because because after removing electrons, after removing two electrons, what will happen? It becomes 3d5 configuration is attained. After removing two electrons, 3d5 configuration attained. Hence it is stable. Correct na? Yes. After removing 3d5 configuration is attained, which 3d5 configuration is attained, hence it is stable. So this configuration is stable configuration. That word is important. Hence it is stable. Because of the stable configuration, this is completely difficult and ionization enthalpy has become more. Next question. Why is chromium plus more stable than Cr plus 2? Simple configuration, electronic configuration. Let us write chromium configuration. This chromium configuration. Okay. First of all, we will write first chromium. What did they give me? Cr plus 3 and Cr plus 2 is what we will write. Okay. All electronic configuration of Cr plus 2 I will write. What is electronic configuration of Cr plus 2? Removing, it is argon 3D, it is 3D4, yes. Argon 3D4 and 4s0, correct. What is chromium plus configuration? Remove one more electron. One more. It is argon 3D3 4s0, right? Now, what will happen? They said Cr plus 3 is stable. We will study in detail of this. Cr plus 3, whatever you're taking, okay, in aqueous solutions, solutions, what will happen? This configuration, whatever is there, na, this D4, D3 configuration, it is going to occupy. This is your D3 configuration. 5 orbitals are there. 5, 4, 2, 3. You have written here, right? 3, 3. Right. So, your aqueous solution, when it is there, this is going to occupy. You have two orbitals. One is your EG set and one is T2G. Correct, na? One is your EG and one is your T2G. Now, this in terms of Cr plus 3, 3 electrons by only set. It will not jump. What is the specialty? This is half filled means it is more correctness. Yes, so no, half filled means it is stable. You write, you will write Cr plus 3. Go to the next question. Write on the answer. Cr plus 3 in aqueous solution occupies, you write like this. Cr plus 3, draw this diagram, and then write Cr plus 3 in aqueous solution occupies occupies half filled T2G configuration, hence it is stable. It is half filled T2 configuration, hence it is stable. It is stable. That's all. You'll write this answer and end your answer. Right? That's all. It's half filled, right? And half filled, more stable. So you'll write Cr plus 3 is stable than Cr plus. Hence, end answer. Next question. Why is E naught value? Why is E naught value Mn plus 2 by Mn highly negative? Why is Mn minus 1? Let's see here. Mn, the electrode potential value is minus 1.18. So students, here this electrode potential value, everything I have explained in one short way. Everything gradually, all this electrode potential values I have explained in D and F block, one short video. D and F block, one short video. One short video. Everything in detail I have explained this concept. Of now, the exam last question. So just write two words. Why is E naught of M plus by Mn highly negative? 1, 2, 3 sentences. Reason, answer, solution is to low enthalpy of atomization. This is the number one. Atomization is the number one. Second, due to low sublimation enthalpy. Sublimation P. This is the secondary. Third, low ionization. Write these three reasons. First, they've asked for only 1 mark. To be explained in detail, you can write these. Okay. Next question. Same. Why is E naught of plus? Why see you positive? Why it is positive? And same. I'll give you 2 lines. Again, watch one short video. Is due to high ionization enthalpy. Due to high ionization enthalpy. Second is due to low hydration enthalpy. So again, my request, please go and watch one short videos. It will be easy for you all to get the concept easy. Done. Next question. Why is Fe plus 3 more stable than Fe plus 2? Why stable? Why? Again, same concept comes to electronic configuration. Iron electronic configuration is what? It is argon 3d6 forest. In Fe plus 2, taking 2 electrons out. Argon, it is 6. You're taking out 2 electrons. 4s0. In Fe3, what will happen? You're going to remove one more electron. This becomes 5, and tell me Fe plus 3 half filled. So in this case, right, Fe 3d5 is half filled, and is which no, and no, which is more stable, more stable than Fe, which is Fe plus 2. That's all. All right. Okay, let me drink some water, student. Yeah, I'm done. Sure. Is it easy? Write this. The star mark, the examiner will directly read this. Done. Next question. Is Mn plus 3 oxidizing agent, and it has electrode potential value of 1 point. Okay, so again, as I said, electrode potential values, or the concept of electrode potential, done in one shot. Because it is 1 mark answer, I'll directly write according to the electronic contribution. First of all, manganese electronic configuration is argon PD5, right? Right. Now, what will it do? What will it do? In Mn plus 3, it is getting converted to Mn plus 2. Yes, means it is trying to gain 1 electron, right? I'll write here. It is oxidizing agent, means what? Now I'll show you this, because it can gain 1 electron daily, electron to form Mn. What will happen when it gains 1 electron easily? Mn plus 3. Mn plus 3 means take out 4s2, and it will be 3d4. Then when you're converting this to Mn plus 2, again gain 1 more electron, and what will happen? N plus, correct, na? Which is more stable. That's the state. That's more stable. That's why hence electrode potential Mn plus 3 by plus 2 is positive. Is plus 1 point. Students, I'll again explain this. Before I go to the next question, I'll explain this. See here. What was Mn configuration? Is 3d5 4s. Correct now? I'm writing here. Mn is 3d. Argon I took out, students, for your convenience, because place is less. Now Mn plus 3. Much is this? 3d4, 4 is 0. What is this Mn plus 3 doing? It is gaining 1 electron. Become Mn plus 2. What will happen to the configuration? It is 5. You only see stable configuration. That's why it is oxidizing agent, gaining electrons. Trying to gain electrons, and the electrode potential for oxidizing is always positive. If it is reduction, it's going to oxidizing agent. Students, don't confuse with oxidation. Oxidizing agent, that's why it is positive. Okay. Next question. There's one paragraph based question which is here. Let us see. This is one more question. When a chromate ore A is fused with sodium carbonate and free excess A, and the product dissolved in water, the yellow color solution B is very important paragraph based. After treatment of this yellow solution with sulfuric acid, compound C is, which can be crystallized. When the compound C is treated with KCl, orange crystals of compound D is identify A to D, where write the reaction. So easy. Let us do step by step. First of all, chromite ore. Chromite ore. This chromite ore solution. So chromite ore formula, that is A, right? A formula is FeCr2. What did they say? They have fused this chromite with sodium carbonate. Let us start. They have taken chromite ore. They have fused with sodium carbonate, A2C3. Then what did they say? And the product carbonate is excess of air, and the product what you get is dissolved in water. This okay. First, when I have combined, let us mark this as A. So when I take this, what will happen? First product which you get is sodium chromate. Sodium chromate. Then next product is iron oxide, carbon dioxide. They said, how did I get this? They said an yellow solution compound obtained. This is your yellow solution. Your yellow solution. And this is B. Balance it. I'll take it 8. Then this is oxygen also. No, oxygen also I should add now. So I should add excess oxygen. Becomes 7. Then again I'll make it 2 here. Then chromium I'll make it 8 here, and carbon dioxide is balanced. Balanced. Yes, it is. 4, 8, 8 to yeah, it is balanced. Okay. Now what did they say next? They said they have taken this yellow solution, treatment of this yellow with sulfuric acid obtained. Chalo, let us take that yellow solution. What is it? We have taken yellow solution and treated with sulfuric acid. I'm going to let us take step 2 for us to understand. I'm taking sodium chromate. What is this? I'm treating sulfuric acid. What will happen to this? Na2R07. Okay. Plus sodium chromate plus sodium sulfate plus water. Now what is this? How did I get this reaction? Simple. See here. Give me a clue here. They said yellow solution treated with sulfuric acid can be crystallized from the solution. So you would have seen sodium chromate crystals in the lab, potassium dichromate, sodium dichromate crystals. So this is your crystalline structure. That's how I could trace it. Then what did they do? They have treated this sodium chromate with which one? With KCl. Okay, they have treated this sodium chromate with KCl. Let us take, they balance the reaction, students. I didn't balance, right? I'll balance it. You need to balance the reaction in the exam, student. Step 3, what did they do? They have taken this sodium chromate, whatever you are getting, right? Sodium chromate, Na2Cr2. They said they are treating sodium chromate, and is the D given here? With KCl orange crystal, compound D is rising out. Okay. Said, take the sodium chromate. I'm treating with KCl. What will happen here? You get again potassium dichromate. That is what we are preparing, right? And left out is NaCl. Again, balance it. Na is 2 here, or potassium is 2 here. Now this is now. What did they say? They said what are what. Okay, sure. And they gave me, last thing is orange crystals they gave me. That's why this color, what is the color of potassium dichromate? These are orange crystals. Orange. See, I've taken that orange crystals and have written this. Perfect. Before we go to the next question, so conclusion I'm going to write in the exam. This is where the examiner will give you. What is A? A is FeR2O. Is B, students? It is Na2RO. What is C, students? It is Na2Cr27. It is K2Cr2. All are covered in this. See? Very easy. Chalo. Next question. Why HCl cannot be prepared? HCl cannot be prepared, cannot be used in the preparation of sulfuric acid to acidify KMnO4 solution volumetric analysis. Oh, this is an interesting question. They're asking why HCl cannot be used in place of sulfuric acid. We add, no, when you do the volumetric analysis, why can't I use? So normally, what happens is, what is the role of KMnO4? What is the role of KMnO4? To release nascent oxygen, correct? Na? Because it is a strong oxidizing agent. So I will write, first of all, KMnO4 is a strong oxidizing agent. Oxidizing agent. Because it releases nascent oxygen, correct? What it does is, when you add HCl instead of sulfuric acid, see here, I am taking KMnO4. In the beaker, to add, do I have next page? I don't have. I'll write here. HCl. What do I have? First compound that salt forms KCl. Then more salt which forms MnCl. one more water, and you get chlorine gas. What is happening here? Whatever HCl is there, whatever is there. So this, for being an oxidizing agent, it will oxidize HCl to, here what will happen? Your chlorine gas reveals. KMnO4 being an oxidizing agent, it converts, being an oxidizing agent, it converts HCl to chlorine gas. What is our product? What is our this? Get the nascent oxygen from the ions. What is happening? Here, HCl is not trying to make the particular solution acidic medium. Here, whatever oxygen KMnO4 is produced, that carries the reaction forward. But this oxygen, instead of the final product, it is utilized. It is utilized in converting HCl to chlorine gas, which is not the required product. Right? So I'm again giving you the answer. Clearly understand. HCl is not used to make the medium acidic in this oxidation reaction. Why? Reason is, if I use HCl, whatever oxygen KMnO4 produced is going to be utilized in converting HCl to chlorine gas. That means which itself acts as an oxidizing agent, partly oxidizes the reducing agent. Itself acts as an oxidizing agent and partly oxidizes the reducing. Easy, students? Okay? Yes. Hence, HCl is not volumetric analysis. Okay? Next question. Potassium dichromate is a good oxidizing agent in acidic medium. Why? Is a good oxidizing agent in acidic medium. Why? What is the reason they're asking? Yeah. Potassium dichromate. Let's see. Oxidizing agent. Let us write the reaction. I'm writing the ionic reaction. I'm taking dichromate. Then I'm writing the ionic reaction. What happens? Dichromate, when it combines, I said good oxidizing acidic medium, I'm adding H plus. So the acidic reactions also I did it in one shot. It gets converted to Cr plus 3 and water molecule. To balance this, what did I do? I did the ionic reaction completely. So chromium, I'm balancing this. 3 2s are 6 electrons I'm adding here. When I add 6 electrons here, balance water, add 7 and 14. Reason, I have to say this is chromium, this is plus 6 and this is oxygen minus. Okay, so now let's see. Chromium from plus 6, where is it getting converted to? Plus 3. Chromium from plus 3 plus 6, it is getting converted to plus 3. So 3 minus 6 minus 3, gaining or losing? Gaining or losing? It is gaining electrons from plus 6 to plus 3 electrons. So gaining. Check, students, in acidic medium, it is acting as a good oxidizing agent because it is gaining. It is gaining, right down. It is gaining, right, like this. Gaining 3 electrons in acidic medium. Is gaining 3 electrons in acidic medium. Hence, it is a good oxidizing agent. Hence, K2Cr2O7 is an good oxidizing agent. Correct? Next time. Highest manganese fluoride in Mn4, highest oxidation state, right? Where's the let us rewrite this. Highest oxidation state, is observed in manganese fluoride, whereas highest oxide state is observed in Mn2O7. Why they're asking? Okay, why they're asking? First of all, simple. How do I talk, students? Oxygen in, okay, I'll start like this. First of all, oxygen, what is the specialty of oxygen? The ability of, it combines with everything, right? The ability of oxygen to form multiple bonds, to form multiple bonds, metals, multiple bonds to metals. Because of this, it explains, this explains its superiority show higher oxidation state with metal. Superiority to show highest because of this Mn2O7, it shows the highest oxidation. Yes, simple. Compared to MnF4, it shows more because it has more compatibility to form. This is the next question. Copper does not liberate hydrogen from dilute acids. Why it is not liberating dilute? Have you heard about electrochemical series? In electrochemical series. So in electrochemical series, what do you find, how, where is hydrogen and where is copper? What is the electrode potential value of hydrogen? In the electrochemical series, hydrogen, the electrode potential value is 0.000 volts. It is taken as a standard. There is this copper lying. Copper is below hydrogen. It is below. How much is electrode potential value? This is plus 3.3.4 volts. Now, copper is lying below hydrogen. Can it liberate? Can it liberate hydrogen from acids? Right? You'll write since copper electrode potential value lies below hydrogen in electrochemical series, it cannot liberate hydrogen from acids. Hydrogen, you can write. Okay? So it doesn't have the capacity to displace it. Next question. Which of the following, which of the three transition metals exhibits largest number of oxidation states? Why? Okay, great. Largest number. 3D series students, you know what are there in 3D? Okay, scandium, titanium, okay, vanadium, then chromium, then manganese. Okay, I will write here iron, then cobalt, then nickel, then copper, then zinc. Start from the first one, scandium. It is 3D1. Okay, titanium is 3D2. Vanadium is 3D3. Chromium it is 3D5 because of the stability. Manganese is also 3D5. Iron is your 3D6. Cobalt is 3D7. Nickel is 3D8. Copper is instability 3D10. Zinc is 3. Now you only tell me, tell me. Perfect. That answers the question. Among everything, which element, if I have to distribute the electrons, which element can show maximum? They're asking. Among everything, manganese is one element which shows more number of oxidation. What is the reason? We'll go in detail. When I take manganese, the electronic configuration is argon 4s2. Okay, so 4s2 is this 3d5 2 5 1 2. Now this configuration, how many can it generate, students? Starting from this, I have to see the oxidation state, can go till +7. Correct na? Yes. I have to compare. If I see all the oxidation of all, it can see. Let us take vanadium. Maximum, if I have to take one, I'll show you. Scandium, which oxide? How many maximum? If I say +3, it can go. Titanium The stable, I'm talking about the stable oxidation states which are there. That means it can go to that till that. And this one is this. Vanadium can go till +2, +3, +4, +5. Chromium +2, +3, +6. Manganese, yes, this manganese can go till +2, +3, +4, 6. Right, remaining all +2, +3, +2, +3. That common oxygen, copper +1, +2, zinc +2. Like that, all all get the configuration. It can go till +2. Oxidation states are right like this: +2, +3, +4, +6. Done. Yes. Right, students. That's the question. Next, anything else? No. The series is done. Today we have completed the most important question. So thank you so much for watching. I'll be again coming with questions. Join the Telegram because I'm going to send some notes, okay, of D&F block. I'm going to send the notes. Join the Telegram. Telegram link is given in the description. Thank you for watching the video. Please like the video. Please share the video. Subscribe to the channel. Ani ma'am is always with you all. Take care. Thank you so much.